In the name of God, hello dear students of grade 7. Welcome back to Think About Physics YouTube channel. I'm Masood. I'm a science teacher and I want to be with you with one more subject about the behaviors of gases. This time we are concentrating on temperature. Let's get started. Let me read the information of the temperature. It says how much helium is needed to fill a parade balloon like the one in figure 1. So it talks about this actual balloon. It says how much helium gas is needed to fill this balloon, right? This is the first information. It says the answer depends on the outdoor temperature. So does temperature have any influence on the size of the balloon, on the amount of helium gas is needed to fill the balloon? Does temperature have to do with the amount of gas inside the balloon? Let's read it. Right. Temperature is a measure of what? Temperature is a measure of how fast the particles in an object are moving. This is the definition of temperature. Actually, scientific definition, right? Scientific definition of temperature is a measure of how fast particles of object are moving, right? So scientific definition is the measure of the speed of the particles of an object. Measure of the speed of particles. It's a strange, right? How temperature has to do with the speed of particle, but it has to do with it. Keep in mind that temperature is a measure of the speed of particles, right? Whether this object is, for example, solid, liquid, or a gas, it doesn't matter, right? But actually, ordinary people don't know what this temperature is. Only students know what what this scientific temperature is. For example, if you ask someone which is not a student, you ask him or her what is temperature, he or she says temperature is a measure of how hot or cold something is. It's a measure of coldness or hotness, as it's clear from the first part of the definition, right? Take a look at this definition. It says temperature is a measure of how hot or cold something is. This is not scientific, actually. It's a, let's say, general information. Anyone knows this information. Anyone knows how to actually define temperature. But the second definition is very important. It says, especially a measure of how is a measure of the movement of the particles, measure of the speed of particles, measure of the movement of particles. This is very important, right? I want you to know both definitions, but the scientific definition is the measure of the speed of the particle, measure of the actual movement of the particle, right? Let's keep going. It says, the faster the particles are moving, the more energy they have. The faster the, let me change the color of this. Actually, I'm gonna change it to the yellow, right? Yeah, the faster the particles are moving, the more energy they have, right? For example, instead of say temperature is a measure of movement of particle, you can say temperature is a measurement of energy of particles. It can be. You can replace movement with energy, right? On a hot day, the particles of the gas are moving faster and hitting the inside wall of the balloon harder. On a hot day, let me highlight for you. On a hot day, the particles are moving faster. As I explained it for you, the more the temperature, the more the movement of particles. The more the temperature, the more the energy of the particles. You see, movement and energy actually is the same, and hitting the inside walls of the balloon harder. They push actually they push on the inside wall of the container with greater force, right? Thus, the gas is expanding and pushing on the walls of the balloon with greater force. You see? So, what's the consequence of the hot temperature? The gas is expanding and particles push on the inside wall of the balloon with greater force because they have, let's say, high energy. So, these actually consequences are due to what? These consequences are due to the rising temperature. Rising temperature, right? It says if the gas expands too much, the balloon will explode. We don't actually we don't see this actually. Leave this information. But what will happen if the cool weather is cool? So I'm gonna actually number the consequences due to the rising temperature. For example, what happens to the size of the balloon on a hot day? The first one, or what happens actually when the temperature rises? The first one, I can say on a hot day, this is the first consequence. Excuse me, let me raise this one. This is the first consequence. On a hot day, the particles of gas are moving faster and hitting the inside one, or leave it. The gas is expanding. So number two, gassing. Firstly, gas particles move faster. Secondly, gas expands. Number three, pushing on the walls of the container with greater force, and the force increases. These are consequences of rising temperature on a hot day. Before I finish the actual text, I will draw it for you to better understand the subject. One more thing that I wanna talk about it is what if the gas expands. No, what will happen? We are concentrating right now on a cool day, so leave the hot day. Right now, it says what will happen if the weather is cool on the day of the parade. This is the question. What will happen if the weather is cool on the day of the parade? Let me write it here. So this is the question, right? Question. Question about what? Question about the cold weather. The particles of gas, this is the answer of the question. So, question is followed by the answer. It says the particles of gas is in a balloon will have less energy. So energy actually will reduce, right? And energy will reduce. So we have the opposite situation. On a hot day, energy increases, particles move faster, they push on the inner wall of the container with greater force. Right now, we have the opposite situation. Energy actually reduces, right? What else? So this is the first consequence, particles. This is the first consequence, particles of gas in the balloon will have less energy. They have less energy. This is the first one. And the particles of gas will not push as hard on the wall and the force decreases. The force of the particles decreases. So more gas must be used to fill the balloon. Let me actually number the factors of reducing the temperature. So the particles of gas in the balloon will have less energy. This is the first consequence. And the particles of gas will not push as hard. The force actually decreases as well. This is the second factor. Particles of gas will not push as hard actually on the walls of the balloon. This is the second factor. I wanted to write number 2 on it. So I'm gonna explain the subject for you. Let's move on to the, let's say, whiteboard. Be with me to the, actually, to the end of this video to better understand the situation. I want to draw two balloons, one on a hot day when the temperature rises, and the other on a cold day when the temperature is coming down, right? Be with me. So this is on a hot day. On a hot day, actually, we have a balloon, right? This is a balloon. What do you say about the actually particles inside the balloon? Particles are moving actually fast. They are moving very fast, and they push on the inner wall of the container with greater force. They push on the inner wall with greater force. That's why the size of the balloon increases. So, firstly, velocity of the actually particles increases, or I can say, what are the consequences of rising temperature on the balloon? Firstly, I can say actually particles speed up. What do I mean by particles speed up? Mean they move actually faster. Velocity or speed of the particles increases. Particles speed up. The first consequence or the first outcome. Particles speed up. Right. The second result, what happens to when particles actually speed up, the gas expands, right? The gas expands. So I can say gas expands, right? Gas expands. The third actually consequence, when particles speed up, they push on the, when particles speed up, they pick up more energy. So energy of the particles increases. Energy of the particles increases. Right. The fourth consequence, the force that push on the inner wall of the container increases. So they actually push on the inner wall with greater force, right? In all directions. The fourth consequence, I can say force of the particles increases, or the more force is pushing on the inner wall of the container. Force increases. Right. Let's move on to the cold day, right? I want you to be with me to explain actually another situation. Be with me. Right now, I want to explain, I want to draw the same balloon on the cold day. So we have a cold day. Let me write it here, cold day. What happens when temperature actually reduces, when temperature comes down? So let me draw the balloon. You see, we have the same balloon, but the size of the balloon actually becomes smaller. Yeah? The balloon becomes smaller because of the weather. So weather has a direct influence on the size of the balloon and the volume of the balloon, let's say. In other words, on the volume of the balloon. What do you say about the particles particles within the balloon? Particles actually slow down. Particles slow down. What do I mean by particles slow down? It means they pick up less energy. The energy of the particle reduces. They push on the inside wall of the container with less force, and they slow down. Particles slow down. It means the speed of the particles reduces, and the gas contracts. Instead of expanding, we have contraction. You see? So in this case, and the gas actually contracts. Right. Let me write the consequences for you, and I want you to be with me. The first one. Over there on a hot day, we said particles speed up. Right now, I say particles slow down. Particles slow slow down. This is the first one. Number two, over there on a hot day, we said gas expands. Right now, I say gas contracts, right? Gas contracts. Actually, the signal for a cold day, gas contracts. The third one, on a hot day, we said energy increases. Of course, here energy decreases. Energy of the particles decreases, reduces. So energy of the particles, the third factor, energy of the particle, reduces. The fourth one, on a hot day, we said force increases. Right now, force decreases. Force of the particles decreases or reduces. Right? What do I mean by this? It means particles push on the inner wall of the container with the less force. Actually, this is the comparison between the situation actually taking place on a hot day or cold day. And I want to finish the lesson here. Thank you very much to watch this video, and bye for now.